So it is actually almost exactly 30 years since I started doing this work. Well, I guess I started at the end of my doctoral work at MIT in 87, 88. I started to play around with the issue of what the relationships were between various kinds of environmental stress and violent conflict. I had done my doctoral work on a theory of violent conflict, looking in particular at group identity dynamics, the social psychology of group identity dynamics, basically we, they divisions in the most extreme form, as kinds of dehumanization in conflict. And at the end of my doctoral work, and as I moved into my postdoc, I decided to try to understand what the relationship was potentially between environmental stress of various kinds, water scarcity, deforestation, degradation of agricultural land, and climate change, which was becoming something of an issue among the cognoscenti in those days, and violent conflict, especially civil conflict within societies. And that became the focus of my work for almost the whole of the subsequent decade. The seminal articles that I published, again, exactly 30 years ago in 1991, an article in International Security titled "On the Threshold: Environmental Changes as Causes of Acute Conflict," which basically laid out an analytical framework and a set of hypotheses for how environmental change might produce severe violent conflict. This article was, it turned out, it was serendipitous. There was a sort of a zeitgeist moment. It turned out to be very widely circulated and discussed. It was written up in a cover story in the Atlantic Monthly. It was read by the Vice President of the United States, subsequently Al Gore, and then especially with the research project that I initiated in the wake of the 91 article at the University of Toronto, we did a lot of research of case studies. Haiti in 94, Rwanda, South Africa, the Israel-Palestinian conflict, Philippines, conflicts in India, where there was some environmental component. And we reported on the results of that research, or I reported on the results of the research in the second article, Environmental Scarcities and Violent Conflict, which was published in International Security in 1994. These publications and the panoply of work that we produced, a very large number of case studies that we produced in the early to mid 1990s at the University of Toronto, substantially influenced the conversation around environmental security, produced a great deal of scholarly contention with, frankly, what I regard to a significant extent as ideologically motivated attacks from both the left and the right of the scholarly spectrum, the political left and the political right. But it certainly did initiate conversation. And I'm not going to actually dismiss those attacks because I think there has been some learning over the years. I've certainly learned a lot from my critics. And there's been some accumulation of understanding. The culmination of my work in this area, my early work in this area, was with this book, which Louise mentioned, from Princeton University, Princeton University Press, Environment, Scarcity, and Violence, published in 1999. It basically pulled together everything we've done in the previous decade or so. And at that point, I felt I'd said what I could. That was my statement of my understanding of the field. This book is still in print and still, I think, sells a certain number of copies every year, still seems to have some influence, regarded as something of a foundation book in the field, although the conversation has moved on and much important research has been done since then. But I felt that I actually didn't have much more to say. And I also felt that the conversation had become so ideologically polarized in some way around these issues that we just needed to wait to see what happened. That in a sense, the vindication or the falsification of the hypotheses that I laid out in this work would take several decades to occur. That I was always projecting in my work 2, 3, or 4 decades into the future, saying that the really enormous challenges of conflict arising from environmental stress would arise right about now, actually, 2020 to 2030. And I felt we needed to wait to see what happened, and then revisit the evidence and reach some conclusions. I would say, I believe, and I'm of course not disinterested, that the evidence, unfortunately, I wish I were wrong, but has substantially vindicated the analysis that we did in the 1990s. Now, one important thing that I did in these early works, and that this appeared originally in the 91 article, is I did a very careful and close path analysis of the relationships between various kinds of environmental stress and violent conflict. And I recognized early on that it was generally unlikely that people were going to fight directly over environmental resources, water or forests or soil, that sometimes they might, but that it was more likely that the degradation or overuse or lack of supply, insufficient supply of these environmental resources and services would have a series of knock-on consequences for agricultural production, economic well-being, social divisions within societies. And it would be those intermediate consequences, what we called intermediate social effects, that would ultimately influence the probability of violence. So I felt that it was very important to trace out some of these pathways in considerable detail. And this was the first of two diagrams that I presented in the 91 article, and later was reproduced in the 1999 book, which looks at the relationship, some of these causal pathways between a series of what, as you can see here at the bottom, are called main environmental effects, main environmental problems, and ultimately social effects, in particular, in this case, decreased regional agricultural production. I always focused on food, and I'm going to come back to food in a moment because I think food is a really central factor in this entire story. A couple of things to notice here. First is that there are many causal pathways from even greenhouse warming, as we called it in those days, which we now would refer to as climate change, and decreased agricultural production. Some of those pathways are reasonably direct, such as this one between greenhouse warming and increased infestation and pests that affect crops, for example, and then decrease regional agricultural production. Some are less direct, this one going through coastal flooding and damage, which affects coastal agricultural regions. A lot of our best agricultural land is in coastal regions. And some are quite indirect that involve multiple steps, such as this greenhouse warming affecting hydrological cycles, basically the amount of water in the atmosphere, increasing the frequency of droughts and floods, and leading to decreased regional agricultural production. So there are a lot of pathways. So greenhouse warming or climate change is producing its effects in a lot of ways simultaneously. It's a very powerful cumulative factor across a lot of different dimensions. Secondly, it's interacting with other environmental challenges simultaneously. There's, at the same time, in a lot of regions in the world, that you have the climate change, you have ongoing deforestation, you have degradation of agricultural land, you have overuse and pollution of water supplies, as you see at the bottom here. Notice that ozone depletion is a problem that we actually seem to have gotten ahead of, and now that would probably be removed from the diagram. Acid deposition, similarly. But a lot of the rest of these interaction effects, where the whole is more than the sum of the parts, are still operating very powerfully. In fact, I'd say they're operating more powerfully than ever in many places in the world. And I think these diagrams actually stand up very well the test of time. They're relatively complete, and unfortunately, we now have much more evidence. While these were speculative somewhat at the time when I did these in the early 1990s, late 80s and 90s, now, unfortunately, we have much more evidence to support many of these pathways. Now, that box on the right-hand side, decreased regional agricultural production, features in the next diagram. So this entire causal diagram fits right into that box that says decreased regional agricultural production. So these two diagrams fit together. It took me a long time to figure out how to do that. And all of the things that we saw in that previous diagram affect economic productivity, another critically important social factor. And then you have, again, greenhouse warming have its own, independently of its effect on agricultural production, which was summarized in the previous diagram. You have greenhouse warming affecting a whole series of things that affect economic productivity through other pathways. And here again, we have changed hydrological cycle, changed river volumes, which disrupts hydropower production and decreasing economic productivity. So there's a lot of stuff going on, and it's highly interactive, and there are many different factors involved. And in many cases, the interactive effect means that the total effect of these environmental problems simultaneously is much larger than the sum of the factors taken independently. So you're getting this kind of multiplicative effect. So that's where we were in the 90s. And I hypothesized at the time that these various changes to agricultural production and economic productivity within many societies around the world would cause three main kinds of conflict. Simple scarcity conflicts, where people fight over resources, such as fighting over water at the community level or even between countries, perhaps. Group identity conflicts, caused principally by large movements of migrants who are affected negatively by environmental problems, moving from one part of the world to another and then coming into conflict with the groups that are resident in the recipient regions. So those are very powerful we-they conflicts that are caused by migrant groups. We see, of course, enormous evidence of that around the world now. And then finally, relative deprivation conflicts that arise largely from effects on food supply and economic productivity, where people feel that they aren't getting what they deserve. So there's a gap between what they think they should have, what they ought to have, and what they actually see they are receiving from the economy, in their employment, in their livelihoods, in the real world around them. So there's this sense of frustration, which ultimately can produce a deep sense of grievance. Now, our research in the 1990s suggested that actually environmental stresses of various kinds, including climate change, which of course wasn't a terrifically powerful factor in those days, it was just emerging on the horizon, would not, for the most part, contribute much to simple scarcity conflicts. And in fact, would not produce, for instance, resource wars in the developing world. But we did see a lot of evidence in our case studies of group identity conflicts and relative deprivation conflicts. So that's where we were about 3 decades ago. So this is where we are now. And this is now the climate change problem. If in the 1990 or so, 1991, we were at about this level of atmospheric concentration of carbon dioxide, we are now up here. And notice that there has been very, very little diminution of this curve, change in the shape of this curve over time. It is still essentially an exponential curve. And in fact, even at the end, where you see some of the, where you see some of the impacts of the excuse me again, I seem to have a problem with my arrow here. Some of the impacts of the pandemic on carbon dioxide output, it's almost invisible. You don't really see any change in the shape of the curve. This is one of the charts. I have 2 relatively young children, 16 and 13. One of the charts that wakes me up at night, because we have so far to go to turn this curve downwards to reduce the effects of carbon dioxide on the heating of the planet. And this is where we are going. It's business as usual, and even under scenarios in the future where we actually cut carbon dioxide emissions considerably, we are still warming the planet very substantially. What you're seeing here is a chart of the temperature of the planet, surface temperature of the planet going up, basically going back to the last ice age, 11,300 years before the present. You see that during this entire period here, from that time in the past up to the present, the total variation of temperature on the surface of the planet has been around 0.7 degrees Celsius. And in the last 2,000 years, on the right-hand side, the total variation has been around 0.5 degrees Celsius. And that's been the period of time when humankind has basically laid down the foundations of modern human civilization. Its port cities, its agricultural zones, its transportation networks, its major urban areas. And we are now significantly outside that envelope of temperatures. And we are moving to a place of 2 or 3 degrees warming, where we are going to be staggeringly far outside that envelope of temperatures. And just to be clear, there isn't an ecosystem on the planet that can withstand 3 degrees warming. It doesn't sound like much when you say 3 degrees warming, but when you realize that we're going from an average temperature on the surface of the planet of about 13.5 or 13.6 degrees Celsius to 16.6 degrees Celsius, you have a better sense for the magnitude of the disruption. And as I say, ecological systems depend upon climates that are local to their regions, and almost very few of them can migrate fast enough. This change is happening in virtually a blink of an eye. This will affect agricultural, forest, fishery systems over the entire planet, and most of those ecologies will be shredded by this change. So what does climate change mean for conflict? Just a few summary slides of where my thinking stands right now, and then a couple of final points. First of all, climate change affects conflict through multiple pathways, as I've already described, and its effects are largely indirect, and they occur by interacting with additional stresses that already exist within societies and existing resource use practices, institutional weaknesses, and intergroup cleavages. So societies that are already vulnerable because they have a lot of those additional stresses and institutional weaknesses, especially corrupt and weak states, and deep intergroup cleavages between, for instance, ethnic groups, are going to be most affected by these changes. And climate change's influence, though, because it's indirect, is often going to be obscure. It's often very difficult to trace out these pathways in ways that you can say, climate change is a principal factor in producing this conflict, even though its influence might actually be very powerful through multiple pathways, as we've discussed. Climate change is causing these big six effects here. And these are the ones I would emphasize coming out of our research in the 1990s, but I haven't seen any particular reason to change these conclusions. These are the ones that have the really extreme social impacts on agricultural production and economic productivity, extreme droughts and floods, extensive mortality of forests, more and larger storms, rising sea levels, urban heat emergencies, and widespread water scarcity. That's a pretty good summary of the kinds of challenges that climate change is producing for societies around the world. These impacts, combined with the kinds of other stresses I was talking about, including socio and political stresses, weak states, and corruption and the like, and economic divisions of various kinds, to inhibit food production, weaken and undermine economies, deepen intergroup cleavages, provoke mass migrations, and further weaken governments because they are overloaded with challenges that they have to resolve. And also, one thing that we noticed in our research is that frequently when you have significant environmental stress in a society and certain resources such as water are becoming very scarce, you find that in societies with weak states, that powerful groups will take advantage of the scarcity to basically do what economists call rent seeking. They capture access to the resources, say to the water, and then extract exorbitant profits from poor groups and weaker groups in the society in order to benefit from the scarcity. And that, of course, further weakens the society, weakens the economy, and ultimately weakens governments. Constrained food production, weaker economies, debilitated states, and deeper intergroup cleavages, all those things I just mentioned in the previous slide, have these two consequences that are very important for conflict theorists. They boost grievances, they make people angry, they make people frustrated with their situation, they encourage people to identify target groups that they blame for their situations. So these changes boost grievances that motivate violence, and they also change what conflict theorists call the structural opportunities for violence. Basically, by weakening security agencies, by changing the power balances within societies, they create structural opportunities for actors to try to actually engage in violence. They may, for instance, weaken the government, weaken the state in ways that make these aggrieved groups more able to attack the state and engage in civil violence or revolutionary violence against the state. These conflicts are usually subnational. Climate change is going to produce most of its security consequences at the subnational level. I think that's something that's now widely understood. So a couple of last points in my last 5 minutes or so. Much of this is well known, understood, and somewhat in the past. But where are we going now? Over the last 20 years or so, I've been focusing on how societies innovate in response to complex stresses like the ones we've been discussing. And I've also adopted what one would call a complex systems view of these challenges, basically applying the tools of complexity science to understanding these kinds of dynamics and the abilities of societies to adapt. And one of the key concepts in complexity science that is really relevant here is the idea of tipping events. The fact that complex systems, which include the climate system, which includes social systems, often have this capacity to flip from one state to another, often in a very unexpected way. And one way of representing a tipping event is something called an energy landscape, which is diagrammatically shown here, where you think of a ball on a surface that has a lot of dips in it, and the ball can flip from one of those dips or one of those basins to another basin. They're called basins of attraction. If the ball is hit hard enough. But there's something else that's going on that is frequently not understood. In many cases, the landscape is a self-changing shape. The basin of attraction, the stability zone for a particular social society or a climate system is becoming shallower and shallower. So it actually makes it harder, or excuse me, easier, much easier for a shock to flip the system from one state to another. And I think what we're seeing around the world right now is that there's a substantial loss of resilience in a lot of social systems. Their basins of attraction are becoming shallower. I think the climate itself might be becoming less resilient to perturbation. And so it's more likely that we're going to see cascades of tipping events in the future as a result of this loss of resilience in both natural and social systems. One a paper that has been released relatively recently that I think is enormously important in this line of thinking focuses on the possibility of cascades of climate tipping events, where you could get a change in one element of the climate that then causes tipping events in other parts of the climate. And the authors of this article, who are some of the world's experts on tipping events, climate tipping events, made the point very clearly. They said the clearest emergency would be if we were approaching a global cascade of tipping points that lead to a new, less habitable hothouse climate state. We argue that cascading effects might be common and examples are starting to be observed. They identify a series of tipping possibilities in the world that are actually linked together sort of by teleconnections around the world, including, as you can see, changes in the extent of Arctic sea ice, that then can have consequences for Greenland, the Greenland ice cap, which could affect the Atlantic circulation, which seems to be slowing down already, which then could reach as far south as Antarctica and also the Amazon rainforest. So we are dealing with a system that may actually be on the precipice of a series of very sharp changes at the climate level, and many of those sharp changes would have enormous social consequences and produce tipping events in those societies too. And then the last point I want to make, I mentioned I was going to talk about food, is that I think this is really the linchpin issue. If people don't have ready access to food, it has enormous emotional and social consequences, as well as economic consequences, of course. And one of the things that climate scientists are now starting to focus on and realize is enormously dangerous is the possibility that we could actually have a series of food shocks globally, more or less simultaneously, what is now called the risk of simultaneous global breadbasket failure. And I think that we are in a situation where we could see these things develop even in the next few years of real consequence. We've had a 30 to 40% drop in the yields in the agricultural zones of Canada, for instance, this summer. If that kind of thing happens in 3 or 4 major food producing regions in the world, it will have global consequences for food prices and certainly for instability. The last time we had a major food shock in the world during the right about the time of the 2008-2009 financial crisis, there was civil instability in almost 60 countries around the world. These folks say that in their analysis, they quantify the changing risk of low production for the major food producing regions over time. We show an increasing risk of simultaneous failure of wheat, maize, soybean crops across the bread baskets analyzed. You can imagine what the consequences for that would be for global security and civil stability and national security around the world. My last point, actually last 2 very quick points, because I think I'm within a minute of finishing here. It has been common over the last decade or 15 years to talk about climate change as a threat multiplier. I actually think that is a term of some utility, but I think it's of diminishing utility because climate change is becoming such a powerful factor in shaping economies, agricultural production, and destabilizing societies around the world, that it is now a threat, not just a multiplier of other threats, but it is now a threat in itself. It is going to become increasingly dominant as we move vertically on that line that I showed before towards 3 degrees warming. And then the last point I would make is one I don't have a slide for, and it's a point that might be a bit controversial. But I think that the military and security establishments of the world have a vitally important role to play. But it's a role that can't be described more as a holding action, to try to sustain as much stability in international and national systems around the world for as long as possible, with the hope that humanity is actually able to mobilize itself effectively to get carbon emissions down and bend that Keeling curve that we looked at earlier down flat and ultimately in a declining direction. We can't solve this problem with military interventions. At best, the military interventions can sustain social order for a long enough period of time so that humanity can deal with the underlying causes, which are rising emissions of greenhouse gases. Thank you very much.